Good morning. Tuesday, October 20th. Students will learn about potential and kinetic energy through a FED interactive called Energy Skate Park Basics. Both cohorts will work to finish it today. The paper copy should be handed in when it's due on Tuesday, October 20th for cohort A and Friday, October 23rd for cohort B. At-home students, cohort B. Students at home were given the interactive simulations packet on Friday, October 16th. If they have lost the combined packet attached as below, they will complete it by copying all answers on notebook paper or by printing out both documents at home. Paper packet due October 23rd when you come into school. In-class students, cohort A, the teacher will give you a paper copy of a packet called Interactive Simulation, Energy Skate Park Basics, Potential Energy and Kinetic Energy. You are expected to complete this packet by the end of class today. Please hand it in to the teacher. So if for any reason you're at home today and you don't have the packet, I have included both documents here. I've combined it into a single packet, but this is how it appears in the paper packet. So if you don't have your paper packet or don't have a printer, you can also print this out if you have a printer at home. Otherwise, you're going to be answering all questions on a piece of notebook paper. So Energy Skate Park Basics begins with a potential energy activity. It says, did you know potential energy is stored energy that can be used for motion? The investigation question for the potential energy portion is what factors affect the amount of potential energy as an object has? So you may need to make a prediction. What factors do you think the amount of potential energy on an object has? You're going to type your prediction or handwrite it on your paper packet here. The procedures call for you to select the intro activity. Check the pie chart, bar graph, and grid box check boxes. And you're going to follow the directions. It says place the skater at the top of the track at 6 meters. Watch as the potential energy changes as the skater moves from 6 to 0 meters and back to 6. Make observations. So for you to access this simulation, you go to this site here. And you're going to stay on the intro. And this is the person here. So if you show the grid, you'll be able to see that they're at 6 meters. It also said here on this packet that you're going to check the pie chart, bar graph, and the grid. So pie chart, bar graph, and the grid. So if in order for this to work, you have to have those checked as well. Do not change the speed, do not check it, and do not change the mass at this time. So the directions, it says for you to place the skater at the top of the track at 6 meters and watch. And you're going to make observations by either typing it on the document if you can't find your paper packet, or by writing it on the paper in the packet that you were given. So basically, you place the skater up here at 6. If you place them anywhere off the track, if it's not hitting this gray line, all right, it's not accurate. So what you need to do, I like to do it in slow motion, and you can pause, pick him up, and put him right at the 6 mark. Oops. And he's not moving because you have to press. All right. And you just want to make observations here. You can put him back on normal. And here on this, you're going to make observations. Then it says, watch as the potential energy changes as the skater moves from 6 to 0 and back to 6. So it's over here that you're looking here. Here's the key. Green is kinetic, blue is potential, red is thermal. It's telling you to focus for this activity on potential. Watch it as it goes up, down, up, down, up, and compare this. Type your observations or write them on the paper in the box below. Then you're going to move to the next part. You have positions of the skater on the grid. By the way, the only way you can type on this is you have to make a copy of the document. You can't type on the master document, or you can do it on notebook paper. All we're asking here is for you to put an X. Does it go there, 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 or there? So you have to determine only one of those will have an X going across at 6. All right. And then you're going to have to also place him at 4. So you can stop, you can restart, you can reset. This time you're going to have to go pie chart, bar graph, grid, and this time you're going to start it at 4 and make observations, watching only the potential energy, the blue, for this activity. All right. And then you're going to stop and you're going to reset, pie chart, graph, grid. It also wants you to do it at 2, making observations here. So you're going to put an X in one of these going across for 6, one for 4, one for 2, and again it's 0. Why 0? I know that's silly. Look where 0 is, but that's what it wants you to do. So you just do it. Where do you think what's going to happen when you place the skater at 0, which is right here at the very bottom? Wonder, is it going to be high potential energy, medium, medium, low, or low? All right. Then you're going to reset the simulation again, and this time you're going to place them again at 6 meters. But this time you're going to slide the mass of the skater to small and make observations. Small, make observations. Which one is going to have the X going across? Then you're going to slide the mass to the skater to large and make observations with 1X. And then, of course, medium is the default. All right. So the medium is the default. You're going to set it to small and then to large. And then you're going to, when you reset it, make sure you reset to medium. And of course, it's only going to be 1X going across. Then you're going to answer the conclusion questions. When would the skater have the most potential energy? And then draw and label the diagram below. Another reason why I gave it to you on paper. It's easy for you to draw this than it is on this form. There is a way to do it. It takes you more time. So when you're done with that, the next pages that I have shared with you is, it's still part of the same packet. It just is a different document here. Now you're going to be looking at kinetic energy with this skater. As it says, kinetic energy is the energy of motion. Now you're going to be looking at the factors affecting the amount of kinetic energy an object has. This time, you're going to be looking at the green and only the green. So again, you're going to set the pie chart, bar graph, and grid, except this time when you release the skater, you're only going to be tracking what's happening with this green bar. You can ignore the potential and the thermal. But this total also is suddenly important. Okay? So it's the green kinetic energy for this particular second part of the packet. Make your prediction. Which factors do you think? And then go through one by one. This time, you're going to be making observations about how the kinetic energy changes. Again, it has tables for you to fill out. You'll either put an X here, 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 or here based upon what you observe. And then you're going to set it to 4 and then 2 to 0. And then again, there's another reset. And this time, you're going to be tracking the speed. So here, you're going to need to put the speed button on for the kinetic energy portion. All right, I just want to point out to you, I'm going to stop it for a second. This is 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11. So I just showed you what those tick marks are. If you need to replay this video at any point, please do so. but that's how you log in speed. All right, there's no numbers associated with the dial. All right, but each larger tick is a whole number: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And each halfway tick is a halfway mark for each one of those. Um, and you want to also mark this here, make your observations, start it at different heights, observe the changes in the speed, and answer the conclusion questions, including a drawing again with the label below. Again, easier to do on paper. Okay? And this is due at the end of class. Please stay focused with your attention on this activity so that you finish this lab today. Thank you.